Hey, what's going on, everyone? This is a video that's going to be a brief overview over line segments, in particular the segment addition postulate. The segment addition postulate states if Q is between P and R, and it has a picture on the right hand for us to kind of observe. So if Q is between P and R, then PQ plus QR equals PR. So this is basically a fancy way of saying two parts equal the whole. So this part plus this part will equal the whole thing. That's basically, in a fancy way, what it's saying. And then also more so on that postulate, if PQ plus QR equals PR, then Q is between P and R. So let's look at an example real quick. It says find X and RS if S is between R and T. So it's nice to stop there and go ahead and draw that on your diagram so you can get a good visual going. We have supplied a number line, but I recommend even if one wasn't given, it's still helpful to draw a line segment. So we have R and T, and it says S is in between R and T. So it doesn't tell us where in between, so it really doesn't matter where you put it, just put it in between them. So I'll just put it here. This is S. So if RS, this part here, is 3x plus 2, and ST, which is this guy right here, is 18, and RT, so that's the whole thing, is 5x, and it wants us to find X and RS. So we just use the line segment postulate, which again just states that the two parts equal the whole. So to translate that from English to math, in this scenario, that looks like this. Part 1, which is 3x plus 2, plus part 2, which is 18, equals, and then the whole thing, it told us is 5x. So let's go ahead and simplify that. We get 3x plus 20 equals 5x. Now we need to solve for x, so that's algebra 1. So we get all of our x's on one side, all of our numbers on the other side. So minus 3x, minus 3x. So this goes to 2x equals 20, which means that x equals 10. So to get RS is 3x plus 2. We just found x, so you just plug it in. 3 times 10 plus 2 goes to 30 plus 2, which is 32. Example 2 is virtually the same, so I'll skip that one and look at example 3. Example 3 is really the same thing. The algebra is just a little bit tougher, so I want to cover it still. So it says find the value of x if n is between m and p. So again, let's go ahead and draw that on our line segment, m and p. And n is just somewhere in between. It doesn't tell us where, so it doesn't really matter where you draw it. You just put it in between them. mn is x squared. np, this part right here, is 3x. And the whole thing, np, it tells us is 40. So we still use the line segment postulate. The two parts added together will equal the whole. So part 1 is x squared plus part 2, which is 3x, equals 40. So this is a quadratic. So to solve this, you're going to have to factor. So we move the 40 to the other side. So minus 40 equals 0. Now to factor, I like the x method, so I draw this x. I put a times c here and b here. A, b, and c represent the first, second, and third coefficient. So a is here, which in this case is just 1, b, and c. So negative 40 times 1 is just negative 40. And then our middle coefficient is 3. So now we're going to look for two numbers that multiply to be negative 40, but add to be 3. So in this case, that's going to be 8 and negative 5. And again, it's helpful just to double check real quick before you keep going. So just double check, 8 times -5, that is -40. And then if you add 8 and -5, you get +3. So this works. So factoring the left-hand side, we can now say x plus 8 times x minus 5 equals 0. Now in Algebra 1, we call this the zero product property. Basically, x plus 8 and x minus 5 both just represent a number. So you have one number being multiplied by another number, and that equals 0. So that's going to occur when either one of the factors is 0, or if they both are. So basically just set each factor equal to 0. So x plus 8 equal to 0. So x is -8. Set x minus 5 equal to 0. X equals 5. Now, since this is geometry, we don't have negative distance, so you're always just going to take the positive one. So in this case, that's 5. So now it wants us to find NP, which NP is just 3x, and we have x, so we just do 3 times 5, which is 15. Okay, lastly, segment bisector. So a segment line or plane that intersects a segment through its midpoint. This is the definition of a segment bisector. And it tells us that line segment QM, in this case, is congruent to MR. And ST, the line ST, bisects the line segment QR. Basically, what a bisector does every time is it just cuts something in half, a perfect half. So bisectors, even though the name might look intimidating, is actually a pretty easy thing because it just means something's cut perfectly in half, which is really helpful and makes the math a little bit easier. So example 4, line T, which is this guy right here, bisects AY through the point M. So that all that information told us that M is the midpoint between A and Y. And these tick marks indicate that both of these sides will be equal. So AM is 3x plus 6, and MY is 2x plus 10. And it wants us to find AY, which is the whole. So first we got to find x. And again, we know that AM is going to equal MY because line T bisects it. So these are split into perfect halves. So these two halves are going to be equal. 3x plus 6 equals 2x plus 10. So now just solve algebraically, get all your x's on one side and all your numbers on the other side. So x plus 6 is 10, minus 6 minus 6. So x equals 4. And it wants us to find AY. So you got a few options from here, and they're all equally correct. You could take either one of these halves and just double it, and that will give you AY, the whole. So you could do 2 times 3x plus 6. That will give you the whole thing, because again, 3x plus 6 is only half of the line. So if you plug x in as 4, so you get 2. 3 times 4 is 12, plus 6. This goes to 2 times 18, which is 36, and that gives us the answer. But just to show that you'll get the same number, I'll go ahead and do it with the other half. So 2 times 2x plus 10. Again, x is 4, so this goes to 2 times 8 plus 10, which is 2 times 18, which is also 36. Another way you could do it is, again, you know by the line segment postulate too, that if you added these guys together, that will also give you the whole thing. So you can add these together, combine your like terms. So 3x plus 2x is 5x, and 6 plus 10 is 16. Plug x in as 4. So 5 times 4 plus 16 goes to 20 plus 16. This is also 36. Again, you do not need to do each and every one of these. I'm just showing you all the different ways you could kind of think about solving it and get the same answer. And that's it today, guys. Thank you.